Hi, this is Kevin Trainer, and welcome to the tutorial for the coding assignment associated with Zelle Chapter 9. Chapter 9 is about simulation and design. And we're going to, a lot like the program that Zelle spent a lot of time on in the chapter, we're going to simulate a game for our tutorial example. And the game that we're going to do is a simpler game than the racquetball that he did. And it's a dice game for children called Beat That. Okay. And I've got a link here to a description of the game. This is a site that has this page is all about dice games, and this is the same link that I'll be putting in the instructions for exercise 1. Okay, because both games are described in the same site. So this is a game for children where they roll dice. And what they're trying to learn is the value of a place in the number system. So what they do is, at the simplest, they roll 2 dice. And then let's say they roll a 6 and a 7. Well, then they have to decide which is going to go into the tens place and which is going to go into the ones. For us, that's easy. 7 in the tens, 6 in the ones, 76. Okay, so in the simulation that we're going to do, well, there's not going to be any user who does that kind of choosing of which order we're going to put the digits in. It's a pretty simple task for us, so we're just going to write a function to do that for us. It's going to choose from the options. Okay, and we're going to write a program that's going to simulate a multi-round game of Beat That for 2 players using 2 dice. Okay, so that's the problem that we're going to be solving. And of course, I've already solved it, and I've got a version of the program that I can run to show you how it works. Okay, so let's stop that and start it up again. So it says, welcome to Beat That. Please enter the number of rounds to be played. So we're going to let the user choose a number of rounds, and this is pretty usable. For instance, it allows the user to just press enter, and we stop and we say player A has run 0 round, player B has run 0 rounds. Okay, so the 2 players are called player A and player B. Okay, and just by pressing enter, we didn't really run any rounds. Okay, let's run it again. So the other way that we can run no rounds is to put in a 0. And it does just that, it plays 0 rounds. Okay, and let's accidentally not put an integer in. So instead of 2, let's put in 2.2. And in a really user-friendly way, it's going to say an integer was expected. You entered 2.2, and it's going to reprompt. Okay, or if we really give a blatant non-integer like hi mom, well, it's going to tell us that we did that, and it's going to reprompt. So if we give it a proper input like 2, okay, it's going to run a 2-round game. Okay, so here's the output from round 1, and here's the output from round 2 there, and then here's the summary of the game. Okay, so in round 1 it says player A's turn. Player A rolls 5-1, Player A chooses 51, so they put the 5 in the 10s and the 1 in the 1s. Player A's turn score is 51. So they took their turn and their score for that turn is 51. Player B's turn, player B rolls 6-3, player B chooses 63, player B's turn score is 63, player B wins the round. Okay, and now we get into playing round 2. Player A's turn rolls 1-5, chooses 51, score is 51. Player B's turn rolls 1-5, chooses 51, turn score is 51. The players tie the round. Okay, so if player A has a higher turn score, then player A wins the round. If player B has a higher turn score, then player B wins the round. If they tie, then they tie the round. Okay? And then we get a summary of the rounds in this game results. Okay? Player A has won 0 rounds. Player B has won 1 round. Okay? Player B wins the game. So in terms of the round score, okay, if player A wins a round, they get they score 1 in rounds. If player B wins the round, they score 1 in rounds, and if they tie, they both score 0 in rounds. Okay, so that's how the program's going to work. Okay, and we've even seen a tie. It's possible to tie the game. You don't get a lot of those, but it's possible to do. Okay, so it's possible to tie a round. It's possible to tie a game. All right, so that's what we've got. Now the approach that we're going to take is going to be very similar to the approach that Zelle took in Chapter 9 for this simulation of the racquetball game, okay? And it's going to be similar in that we're going to create a structure chart. And this isn't really accidentally, okay? It's not accidentally that we're doing one of these kind of game simulations, because this is a way we typically teach new programmers to design and write and test more complex programs, okay? It's easier to understand the rules of a game than some kind of a complicated business research process, and it's more fun as well, okay? The other thing that we're doing that's kind of common is as soon as you begin to design and write bigger programs, then one important aspect of that is going to be that you need to figure out how you're going to break down your code into functions. Now, the approach that we've been taking in the course previous to this is kind of the naive one, where we begin to write our code in main, right? And then when it gets too big, then we begin to factor out functions in a reasonable way, okay? Well, when we're designing a more complex program, we probably want to be more thoughtful than that. And the concept or the tool that was introduced in the chapter we see here, they're alternatively called program structure charts, module hierarchy charts. There's a rectangle on the diagram for each module, and in procedural Python, modules are functions, right? When we get to classes, if we get to building more object-oriented parts, well, a module could be a class, or it could be a method within a class. But with the parts that we're building so far, it's typically a function. So the boxes that we have, the modular parts are going to map to functions. All right, and two things we're going to decide when we draw the diagram. One is how we're going to divide up the problem. The fancy name for this in computer science is functional decomposition. We take all the function and we decompose it into the right kind of parts. And again, we're going to pay attention to the rules that we've talked about previously, that, when we create a module or a function, we want it to have high cohesion and low coupling, right? And we can kind of do that ahead of time, just kind of looking at the problem and having maybe some kind of sense from experience. You can kind of see how these play out. So at the very top box has the name of the program. Beat that. It's going to be implemented in the function called main. And then it's going to call 3. So let's call that top box level 1. Okay. And then the next level here, let's call this level 2. So on level 2, we've got 3 functions: get number of rounds, play round, print game results. Okay. And then when we break down play round, it breaks out into play turn. And then when we break down play turn, it breaks down into roll dice and choose value. And roll dice, if you really want to do it the way I do it, which you don't have to, but this is the way I like to do it, we're going to factor out roll die. So we're going to go all the way down there. So the deepest of the code is 1, 2, 3, 4, 5 levels down. Okay, and it's not too surprising I picked this design. It's a lot like the design that Zelle had in the example that he did in the textbook with racquetball. Okay, so I wouldn't say that all game simulations are like this, but they're probably pretty similar, right? The other thing that we highlight in this kind of diagram is what's the interface to each of the functions. And by the interface, we mean what are the parameters that we pass in when we call it, and what return values are being sent back to the calling code. And sometimes when they draw these kinds of charts, they have fancy little arrows with little dots that are either filled in or hollow, and we're not doing anything that fancy. All we're going to do is we're going to list the parameters in, if we have any, and if we do, we'll have an arrow that shows it's going down into the function. And then we're also going to list return values back, and we're going to have an arrow that shows that they're going back to the calling code. That's what makes them a return value. And if we don't have any parameters in, well, then we're not going to have anything there. And I think what I did pretty consistently is the parameters that are coming from the calling code I put on the left side of the line, and the return values that are going back to the called code I put on the right side of the line. And I drew this one by hand. There's not really a good template in Lucidchart or in Visio for this. And I used to draw these years ago. These kind of diagrams have been around longer than 40 years. Um, that's when we really started to concentrate on modular programming about 45 years ago. And and they've been popular ever since, right? So when I began this, you had to draw them by hand. And so now I drew this one by hand, just to show you that it can be done. The other thing is we typically don't hand these in. Like pseudocode, these are the sketch that you do before you paint the oil painting, right? And, you know, sketches that artists do before the oil painting are valuable if the artist is a great master. So there are sketches by Leonardo da Vinci that are, and people of that caliber that are, art in their own right. Okay. But typically, when you and I do a sketch for some kind of project that we're going to do, well, the sketch is how we get ready to do it. And then, the code or whatever we're going to build, it comes to represent the project after that. Okay. So we're not going to maintain them both. Okay. We're only going to maintain the code. All right. So you can do this by hand. It doesn't have to be quite so neat. So let's look at how these functions relate to each other. Beat that is going to call get number of rounds. It's not passing anything in. It's getting back rounds to play. Okay, that makes sense. Then it's going to call play round. It's going to pass in the round number, and it's going to get back a round score for each of A and B. Round score A, round score B. Okay. Now, this is the part of the solution that's going to loop. It's going to loop around for the number of rounds that we have. Okay. And sometimes on this kind of a diagram, you'll see a kind of circular arrow here to show that this is the part that's going to loop. And then finally, we're going to print the game results, and we're going to pass in rounds 1A, rounds 1B, okay? And we're not going to pass anything back. Okay, and here I guess I broke from the I broke from the left side, right side kind of rules about where things are, so you have to pay attention to the arrow. So those are the three round one functions that we're going to write. Play round is going to call play turn. Do we have to break down the turns? No, but it turns out to work out really well. And I've been working on this problem for a number of years. And quite a few students have liked solutions where we specifically break out the turn. And so that's the way we're going to do it here. So play round is going to call play turn. Okay. It's going to pass in the player name. So for each round, we're going to call play turn once. We're going to call it once for player A. We're going to call it again for player B. And each time we call it, we're going to return a turn score. Now the turn score is going to be the same as the choice that they made of which way to order the dice. Okay, and then play turn, which is on level 3, is going to call roll dice, which is on level 4. Okay, and it's going to pass in the number of dice, and it's going to get back a list called rolls, which is going to have a list of ints that has the value of the rolls, each of them an integer 1 through 6. Okay, the roll of the die. And could I have made this less general and call this like roll 2 dice because it's a game for 2 dice? Yeah, I could have. I decided it's a little more general this way, and I liked it. So I've come off on the more general side. Okay, so now that we've got the two roles back, now the play turn is going to take them and pass them into choose value. And choose value is going to decide which of them is going to go first. Okay, then it's going to do the math to turn them into an integer. Okay, and so a choice we get about is an integer value. So if it gets a 5 and a 7, okay, it's going to do the work to figure out that the 7 should go first, and it's going to pass back an integer 75. Okay. Okay, now one of the things that's interesting is what choose, the interest, the return of value from choose value is going to be called choice. Okay, but once it gets up to play turn, once we have the choice and we're going to return it to play round, the choice becomes the score for the turn. So we're kind of changing context. Okay, here we're making a choice, but once we have the value, it's not just our choice, it's our score for the turn. Okay, and then roll dice is going to call roll die 2 times. And did we have to factor this out? No, that we didn't. I've said a number of times that these things that we might change the way that we do. We'd like to isolate them in their own function to hide the assumptions. And of course, I always like to show that so I can kind of emphasize that with you. Okay, so that's the approach that we're taking. Let's get started. Okay, so we're going to create a new Python file called beat that. Okay, let's make this a little bit bigger so you can see it. And what I'm going to do is I'm going to copy over code from my already coded version. Okay, so my doc string, simulate a 2-player and 2-die game of beat that with a user chosen number of rounds. And then we've already taken peek in previous assignments that to do this random number stuff, we're going to use randint from the random package. Okay, so now let's take a look at what's going to go into main. Okay, now you'll remember main is this a box that has the name of the program. This is the one that's going to call get number of rounds. In a loop, it's going to call play round, and then it's going to call print game results. Okay. All right. So we've got get number of rounds right here. Okay. And then let's look at the middle of this code. Let's bring this over. Okay, and then let's look at the end. All right. Okay, that's it. That's all of main. Okay, and this doesn't look terribly different from the main code that we see in the racquetball example in the Zelle chapter. So let's just take a look here. We've got red underlines because we're calling functions that we've yet to define. Okay, so we need to be able to accumulate the number of rounds won by A and the number of rounds won by B. We saw when I ran the code that we have a welcome. So we want to do a welcome. Okay. And then we're going to call a function to get the number of rounds. Okay. So rounds to play here is an int. Okay. 0 or greater. Okay. So then we say for I in range 1 to rounds to play plus 1, because we don't want to just say range rounds to play, because then it's going to number them from 0, and we're going to want to print them out. Okay, so we want to begin with 1, so we want the second value to be rounds to play plus 1. Okay, and we're going to call play around. Okay, and we're going to get back round score A, round score B. Okay, and then we're going to accumulate round score A into rounds 1A and round score B into rounds 1B. And then we're going to print game results, and we're going to pass in rounds 1A, rounds 1B. And if you go back to our chart, you're going to see that not only are we calling these functions the right thing, but the values that we're passing in are not, and the values that we're passing back match up. Okay, and this is one of the key important things about this kind of design tool is we're really focusing on the interfaces between the functions. What parameters are we passing when we call? What values do we get back on the return? Okay. Now, do we want to, where do we want to go from here? I'm going to do the following thing. I'm going to show you a trick called stub versions of functions. Now, these have been called a lot of things. When I was a lad, we would call them dummy versions. Well, that's not good language choice in this day and age, but we did call them stub versions, so that's what we're going to do. So let's define a very simplistic version of get number of rounds. Okay, and what are we going to do? Well, it's supposed to return the number of rounds. Let's just say return 2. Okay, so the first implementation, which is just going to be a stubbed out version, is just going to return a likely value. Okay, we'll write the real version soon. Okay. Okay, so now what's the next thing that we call? Play around. All right, let's create a stub version of play around. What do we pass to play around? Well, we pass round number. Okay. Now, what's this called? Well, when we call it, we're calling it I. Okay, because we're in a counted for loop. That's a pretty good, it's a traditional variable name for a counted for loop. Okay, that sounds good. Okay, what do we return? Round score A, round score B. Okay, round score A, round score B. Okay, so let's assume that A wins and B loses. This is a stub version, so we're going to return 1, 0. All right. Now, it's because we're returning 2 values, it's going to return a tuple. Okay, and then up here, we're just going to immediately unpack it into round score A, round score B. Okay, that looks good. Now let's create a stub version of print game results. Okay, let's do that. So we're going to pass in A rounds 1, B rounds 1. Okay, those are the opposite names from what's up here. And I usually try to use a different name for the formal parameters within the names of the variables that we're calling with, because I try to emphasize to you that we're not able to see the variable up here. In print game results, we can't see round score A. And it kind of obscures that fact if we call the formal parameter round score A. So what I've done in this code is I've used a common approach. Up here, I put the A at the end of the name, and down here I put the A at the beginning of the name. Okay. And I think I was really talking about round 1A, round 1B. So I'm passing round 1A, but I'm calling it A rounds 1. Okay? And do I return anything from print game results? I don't. Okay? But I need some activity. So let's just print something. So I'm going to print with an F string. I'm going to print A score is A rounds 1. B score is B rounds 1, period. Oh, okay. So what's interesting here is that we've we've done a simple version of those things. Now, the one thing that we don't have yet is we don't have a call to main. So let's put a call to main. Okay, so let's test and let's see what happens. Again, we're fudging the number of rounds to 2. A always wins, and then we do a not so pretty printing job. Well, let's see what happens. So we run this, and we get welcome to beat that. A score is 2, B score is 0. So we played 2 rounds. A won both because we forced that, and we got the answer. Well, that looks like we're passing the test. Okay, what if B won? Okay, so let's return 0, 1. Let's see what happens then. A score is 0, B score is 2. What if they tied every round? Okay, well, let's look. A score is 0, B score is 0. You only get a point for the round if you won. Okay, so let's go back to A wins. All right. So where do we go from here? There's a lot of theories about how to do this. There are some people who will press ahead on the stuff that's hard to do first, and then they'll do the easy things last. I'm just going to do things in the order that they appear in the diagram. So I'm going to give us code for get number of rounds, then a play round, then print game results, then play turn, and on. So let's try to create a real implementation for get number of rounds. Okay. Now I'm going to bring over my already coded version of this. I'm going to warn you ahead of time, it's pretty big. And the reason it's pretty big is that I'm doing a pretty user-friendly job. Okay, so let's look down here. Okay. So I want the user to be able to press just enter and then play 0 rounds. I want them to be able to put in a 0 and play 0 rounds. I want them to be able to put in a non-integer and then get prompted to enter an integer. I want them to be able to do that with if they accidentally put in a float value. And the other thing is, if they ask for a number of rounds less than 0, well, then I want to tell them that's an error, and I want to prompt again. Okay, so because we have to deal with no data in case they pressed just enter, and then we also need a valid value. It's got to be 0 or greater. I created a boolean called valid value and I set it to false. And then I have my priming read right up here. Okay, I prompt. And then I have a while loop. Okay. And I'm going to do the while as long as I haven't gotten the plain enter or I haven't gotten a valid value yet. Okay, I'm going to keep on evaluating it. Okay, now when I start, I already have a value from my priming prompt. Okay, so I'm going to go into the try, and I'm going to try to turn it into an int. Okay, and if that succeeds, then I'm going to check it for greater than or equal to 0. And if that's true, then we're going to turn valid to true. Okay, else we're going to print an error message and reprompt. Okay, if when we're trying to turn it into an int, okay, it blows up, well then we're going to catch that as a value error. We're going to print an error message and we're going to reprompt. Okay, so we're prompting from 3 places here, and that's kind of messy, and we're going to fix that in a minute. But then when we drop out of the while loop, we don't know for sure whether we got a valid value, okay, or we came out of the loop because they pressed plain enter, okay. And here I'm currently checking if rounds as string equal the empty string, then I'm gonna set it to the default rounds equal 0. And you know what? I'm thinking maybe this wasn't the right thing to check. Let's change this. Why don't we say if not valid value? Okay, if not valid value, set rounds equal to 0. Okay, so if we dropped out of here without setting the rounds to something, well, we'll set it to 0 because the only other way to drop out is with the empty string. Okay, and we're going to return rounds. Now that's pretty good for me, except that I've got the same code in 3 places. Now I've showed it to you in 2 places before, and I haven't worried about that too much. But certainly if I'm going to prompt in 3 different places, I'm going to factor that out into common code. So I highlight it, refactor, extract method, give it a name, prompt for number of rounds. That's a good name. Say OK. It says, oh, I found another 2, which I'd like to change them to. Yes, I would. So I say yes, and I change replace on that, and I change replace on that. And so now I just have a very simple function that just has that line of code, and instead of having that line of code in 3 places, I factored it out, and I call that in my priming prompt, and I call that in each of the 2 error cases where I need to reprompt. Okay, so let's run a test. Let's run a test. Please enter the number of rounds to be played. Enter. Okay, that seemed to work. Rounds to be played, 0 rounds. Yeah, 0 score. Let's put in, instead of 2, let's say 2.2. I said K 2.2. Let's say 2.2. It gave us a warning. It reprompted us. What if I say the classic "Hi Mom"? Well, it gave us a warning and it reprompted us. And now let's say 2, and it ran 2, because right now A always wins. So A score is 2, B score is 0. So we've replaced the stub version implementation of get number of rounds with real code. In this case, it takes some thought, because this is a pretty user-friendly version, okay? But we were able to test the interface between the main code and this function before we put a lot of effort into coming up with the real implementation. So now we need a real implementation for the next one on level 2, which is play round, which we have a very stubby implementation of. Okay, so let me bring over my code for play round. And in the interest of time, I'm going to bring over all of it, and then I'll talk you through it. Okay, so don't be turned off by the fact that all of it is here. Okay, so what do we have to do? Well, let's look at our diagram. We want to call play turn once for player A and once for player B, and we want to get the turn score back for each of those, and then we want to decide who won the round, and then we're going to return the round score up to the main. Okay, so let's see what that looks like. Well, the first thing that we're going to do is we're going to put out a heading, skip a line, playing round number, okay, and we call play turn, and we pass in the name of the player, A, and what do we get back? Well, we get back their turn score, okay. Now that's the same as the number that they chose, it's just been blessed as the turn score, so it's the same value in a new, more formal context. And then we're going to print player A's turn score is whatever we got back. Then we're going to do the same thing for B, okay? And now we have to decide who won the round, okay? And some of this is easy and some of this takes a little bit of thought. So we compare the turn scores. So if it's A is greater than B, then A wins. If A is less than B, B wins. And else they're equal, okay? So they tie. But the other thing we have to do, in addition to printing the outcome of the round, okay, we need to send back a round score, okay? Because we're returning A round score, B round score, okay? And here we are, okay? We're returning a round score for A and a round score for B, okay? So we have to set those. And they're not hard to set if you realize that you can just set them both in each of the cases. So if A has 1, A scores 1, B scores 0. If B has 1, A scores 0, B score 1. If they've tied, A scores 0, B score 0. Return the scores. Okay, that's pretty good. Now, can we test this? We can't test this because we don't have a play turn. Yeah, you're right. Okay. Well, let's just create a stub implementation of play turn. All right. So I'm going to go find my play turn and give you a stub implementation of it. So let's go down right after play round, and we've got play turn. And play turn is supposed to return, okay, it's supposed to return a turn score, okay. Okay, well, that has to go on for a turn score, but if we're going to have like a dummy version, a stub version of play turn, it's going to return a single value, okay? And let's say return 89. So what we're going to get when we test this is both the players, both A and B, are going to get are going to choose 89. They're both going to get 89 for the turn score. They're going to tie, and of course they're going to do that every round. So they're going to tie the game. Let's give it a try. Okay, let's run it. Okay, let's say we want to play 2 rounds. Okay, 89, turn score 89, players tie, 89, 89 again. Okay, then A score is 0, B score is 0 because they tied twice. Okay, so we've tested the interface between play round and play turn. Okay, but we're getting not so interesting results because we've picked a constant for that. Okay. So is there anything else to do a stub version of? No. So we'll go right from the stub version of play turn to the real implementation. Okay. And again, have some patience here while you see all the code at one time. This one's not very long. Okay. So here we go. So what's going on here? Well, we're going to print, first of all, we're passing in the name of the player. Okay, A or B. So we're going to say, we're going to print player names turn, player A's turn, player B's turn, and then we're going to roll dice. So, okay, so rolls is going to be a list. Okay, we're going to call roll dice and ask for 2 rolls. So we're going to give back a list of 2 ints. Okay, and then we're just going to print player name rolls, and then we're just going to print the list. It's going to come out as a list. It looks pretty good. Okay, and then are we done yet? No. From whatever we rolled, we need to choose a value. We have to decide what order they're in. Okay, so we're going to call choose value, and we're going to pass in the list rolls. Okay, and it's going to give us back a choice, which is an integer. Okay, so if we passed in an 8 and, well, if we passed in an 8 and a 9, it would give us back 98, right? Okay. And then we're going to print the choice. Player name chooses the choice. Okay. And then we're going to return the choice. Now, interesting here, we're going to return the choice, but how do we get it back? When we call the choice up here in play round, okay, where's my play turn? Play turn. Okay, we call it a turn score. Okay, so as soon as the turn's over, we're taking that value an integer value that's like, what would it be? It wouldn't be 98. It's always up to 6. Okay, so it'd be like 54. Oh, okay. Now, when we returned it, the variable name was choice. But once we register it as the score, well, it's their turn score. Okay, so this looks good. Now, we have a roll dice and a choose value that we don't have any implementation of at all. You won't be surprised to realize that we're going to create stub implementations. So let's just go do that. Okay. So here's roll dice. Okay, so we're getting in the number of dice. All right, okay. And we know it's going to be 2. So let's just pass back 2 values. So we're going to return a list of, so we're actually going to, we're only going to return 1 value, a list that's going to have 2 values in it. And let's say we have a 4, okay, and we have a 6. Okay, that's all we're going to get. So that's the stub implementation for roll dice. Now, choose value. Let's look at that. Okay, so we're going to have a stub implementation for choose value. Okay, it's going to get in a list of roles. I've given it a new name here. Okay, these roles. Okay, and let's we know that we're passing in a 4 and a 6, right? So let's return 64. Okay, again, we're kind of cheating. All right. Okay, then that's ready to test. Let's give it a run. Okay, so how many rounds? 2. Okay, let's look at this. We're getting a little more detail here. Okay, playing round 1, player A's turn. Player A rolls 4, 6. We hard-coded that. Player A chooses 64. We hard-coded that. Player A's turn score is 64. Now we're going to get the same thing for B, but it was able to tell that the players tied. Good. Same thing for round 2. Okay, and we can't really completely tell that we passed the score up, but because they tied both times, the round score for both of them both times was a 0, and that's what we're reporting. So there could be a bug there. We haven't demonstrated that there isn't one there, but we'll find out when we get to real values. All right, so we have a stub version of roll dice. Let's come up with the real version. Okay, so here is the real version of roll dice. Okay, a proper implementation. Okay, so we're going to create an empty list called roles, and then we're going to do a counted loop for I in range number of dice. Okay, and then we're going to append to roles the value we get back from roll die. Okay, and again, could we call randint right here? We could. Okay, I just want to demonstrate to you that you can isolate that die rolling code right there. Now, are we going to create a stub version of roll die? We're not. Okay, roll die is so simple that the real version is no more work than a stub version. So we're just going to create the real version and call randint and return the value. Okay, and we want a value between 1 and 6. Okay, now Now we have a real value, okay? We're really rolling the dice, okay? But we've got a stub version of choose value, okay? We can test this. We are going to see real values emerge, but of course, we're going to choose the wrong one. That's okay. Let's just test what we have, okay? All right. So let's ask for 2 rounds. Okay. So let's see. Uh, Player A's turn a 5 and a 3. He makes the wrong choice, but he got a 5 and a 3. Player B got a 5 and a 1. Makes the wrong choice. Now, oh, what was the other one? A 1 and a 4 and a 5 and a 6. That seems to be working fine. Okay, so that's testing. But of course, the choose value is giving us a hard-coded bogus value. Okay, so now we need a real implementation for choose value. The stub implementation will only take us so far. And I think I mentioned that we've been using this in my class now for, probably 5 years. Okay, certainly 4 years. And and this used to be the coding assignment exercise itself. So I saw a lot of student code on this, and I've probably seen about 6 different approaches to choose value. Okay, and that's okay. All right. Sometimes I think when I'm trying to come up with the code for one, I might think, am I ever going to have more than just 2 dice? Okay. And the answer is, yeah, someday I may want to expand this and have a choosable number of dice, 2 or greater. Okay. So do I want to come up with something that could choose for 2 dice or 3 dice or 4 dice? Well, sometimes that gets complex. What I've done here is something that's kind of ready for more dice, but not really. Okay, so mine is kind of a conglomeration. But again, there are a lot of approaches to this. Here's what I've done. I've got the 2 roles in a list called these roles. Okay, and I'm going to sort this. Now, instead of calling the sort method on the list I've been passed, I've decided to call the sorted function and pass the list in so that I'll get a new list. In this case, I'm concerned that the calling code might want to still list out this list in its original order. I don't know that it's already printed this in its original order. Okay, so I don't want to change the order. So I create a new list by calling sorted. Okay, I pass in the list, and I want them in high order first. So I say use the keyword parameter reverse equal true. Okay, so now sorted roles as exactly that. Okay, they've been sorted. And now here's where I decide there's only going to be 2 of them. Okay, this is a little bit of a cop out, right? I could have written some more general code that could have worked for 2 or 3 or 4 or 5, but I decided, well, we're in a hurry now. We're only going to make it work for 2. So what do? I just unpack it. Okay, it's a list. I unpack it. I have the higher of the 2 coming out first. I make that the tens place. The second one, I make the ones place. And then I just return the tens place times 10 plus the ones place. Okay, and that chooses the right value. All right, so let's take a look at that. Now I think we have a good implementation of all the code. All right, so let's see if it works. Let's make it a little bit bigger. So we want to play a 2-round game. Okay, and let's see. Player A 6-3, 63. Player B 4-4, 44. Player A wins. Player A in round 2 5-4, 54. 6-5, 65. Player B wins. The A score is 1, the B score is 1. Oh, okay. We don't have a real implementation of printing the results yet. Let's go do that. I forgot about that, didn't I? Okay, so we still have a stub version of printing the results. And where did that go? Play round, play turn. Oh, print game results is all the way at the bottom. Well, I'm just going to bring over my real implementation for that. And again, we'll talk through it. Okay, so I skip a line and print game results. And I use a pretty F string to say player A has won how many rounds, player B has won how many rounds. And then, of course, I have to compare their wins. Okay, so if A rounds 1 is greater than B rounds 1, I'm going to print player A wins the game. Else, if A rounds 1 is less than B rounds 1, player B wins the game. Else, the players tie the game. Okay, and I went ahead and gave an exclamation if there was a win, and just a plain old period if there was a tie. And I'm wondering if I did that on the other one. No, I didn't. So when we're doing a turn, let's do the when we're playing a round, let's do the same thing. So if we have a winner, let's give an exclamation. Okay. And if we don't, let's just have a plain period for the tie. Okay, now this ought to look a little better. Okay, so let's run this. Okay, make it a little bigger. Say we want to play 2 rounds. 5-2, 52, 6-4, 64, 1-4, 41, 5-6, 65, 1 for player A, 1 for player B. Player A has won 1 round, player B has run one round. So we don't have any ties, okay? We have a tie game though. That's nice. So when you're running this, just to kind of finalize the testing, make sure you see examples of player A winning a round, player B winning a round, a tie in the round, and then with the game, players, A wins the game, B wins the game, the players tie the game. Okay. You'll probably be more likely to get a tie if you just run enough 2-round games. Okay, I just happened to get one this time out. If you're looking for ties on the rounds, just run a long game. Okay, so here we're going to play, and let's say that we want 100 rounds, and that runs fast. Okay, so player A has won 51, player B has won 41, so that's 92. So we tied 8 rounds. That's a lot. Okay. Okay, so let's look back at the ties. Let's see if we can find some ties. Yeah, there's the tie right there. 31-31. All right. And I'm not going to go through the whole 100. But this is it. If you compare this to to what we were trying to do in the beginning, I think we've done a good job. So this This approach to design, this tool is called either a structure chart, a program structure chart, or a module hierarchy chart, or a program hierarchy chart. It's a technique that's been around a long time, as long as, say, pseudocode. Okay. It really targets how we're going to apportion the code into functions. Okay, and it has us identify the functions and really specifically document what the interface is going to be. Okay, and then when we went to implement it, we used an approach called top-down programming and testing, where we coded the things in the top of the chart first, and the first implementation for each of the called functions was a stub version. That allowed us to test the interface code, okay? And then once we got that to work, then we implemented a real version, okay? And I had intended to do stub versions of level 2 and then real versions of level 2 and then work my way down. I accidentally left the stub in this print game results for a long time, and that worked out okay. Okay, so the order that you do things in doesn't have to be exactly the order I did, but you should do them in an orderly way. Okay, and if you implement stub versions before the real version, you'll get to test the interface before you test the implementing code, and you can find lots of problems that way and save a lot of time and a lot of anguish. So that's it for this one. You guys are going to be doing a different but very similar dice game as your exercise. And I'm just going to invite you to do that, and I'm going to say bye until next time. Bye-bye.